Recursion, the idea through a very simple, actually silly little example, but hopefully that will help to understand the point in recursion. So imagine this, that you have to write a function that calculates 5 factorial. Okay, and I know, okay, this is very easy. You just have to multiply the numbers starting from 1 up to 5, multiply them together. So yeah, reduce multiplication, and it's just a range from 1 up to 6, so it's like 6 is not included. Okay, 120. So I could just write a function fact5 that gives 120 back. But okay, let's pretend that we don't know this. We don't know how to calculate this one. We just know the definition of factorial. So what I mean is that I need to write a function fact5 that takes no input and produces 5 factorial. So here's the idea. Recursion works whenever you have a problem, and you can divide it into 2 parts. Especially if one part is very simple to solve, and the other one is just may not be simple to solve, but it's a smaller version of the original problem. Okay, so in the factorial calculation, this is, if I knew factorial 4, it would be rather easy to calculate factorial 5, because it's just multiplying by 5. So imagine that we have this fact 4. Okay, well, it's interesting that I actually do have fact 4 here, because it has been defined, but the point was that, okay, that's it's not defined. Interesting. I started a new session and I still have that function definition. Okay, well, because probably I'm in the same local namespace. Okay, so normally we don't expect this to be there. It's just, this is take 3, so therefore it's there. But okay, I will show that later. So let's just copy this, because then we have we need to write fact 4 as well, and that would be, by the same token, that would be just 4 times factorial of 3 if there was a function. Okay, so it's well, here is the definition of factorial 3, and then let's just do one more. It's a fact 2, so that will be 2 times the factorial of 1. Okay, well, yeah, it's like, okay, now I can demonstrate that. What happens if I try to evaluate that? Yeah, there is no such function. Okay, so this is all wishful thinking. And but I can now define fact 1, which is just 1 by definition. Okay, so now I can evaluate this. So I have fact 2, now I have fact 3, and I have fact 4, and now I have fact 5. Okay, and I can just ask, so what is the value of fact 5? Okay, 120. So yeah, this is a rather silly thing to do, because, well, that's it's gonna be exactly the point, that with recursion we don't have to do this, but hopefully the logic is clear. That's wishful thinking. If there is fact 4 available, then doing fact 5 is just multiplying by 5. That's that simple. And you see here, so in these 4 function definitions, the function definition looks very similar, right? It's sort of doing the same thing. So whenever we are doing the same thing, then it makes sense to make that one sort of more abstract and just say it once. Okay, so it's like what this is saying that, so let me try to take the pattern here. So if I have factorial n, right, and that would be just n times the factorial of fact n minus 1. Okay, now this looks like rather awful, but and this is not, it's gonna be a valid code, but that's the way of thinking. And it's like, okay, instead of having fact n, so it's a separate function for each input, right? We can just make this to the input. Okay, and now it's like fact n minus 1. It's gonna be just decrementing n. Okay. So this is the idea, and now this is recursive because the function I'm defining, it's already here, and it looks like a circular definition. It is, but the trick here is that, well, I'm sort of calling it a different instance of the function because it's a smaller value. Okay, so that silly way of coding it, it's like having a separate function. That sort of tries to give you the message that, oh, okay, when I do recursive function definition, I'm using the same function, but I'm using it with different input. So therefore, it can work even in a circular definition. So now, of course, if I evaluated this one, this would never stop. Okay, maybe at the end I can try, but I don't want to ruin the video here. So let's just copy this. Okay, because we have the base case, just like fact1 here is just 1. That's a different behavior. So and actually we can make it into 0 because 0 factorial is 1 as well. So we need, it's better have an if statement, and we ask that if we get down to 0, okay, then what do we return? We return 1, otherwise we return the n times the factorial of n minus 1. Okay. Voila, that works. And that's like, I make it bigger. Oh, that's a big number. Okay. So in a way, it's like using the function name exactly the same function in the definition of itself. It saves us from defining many functions. Okay. Well, that's sort of you can think of it as like almost as a separate function. So factorial 3 is a function that calculates 3 factorial. Well, okay, we do it that way, that is the factorial of 3, but it's sort of the same idea. Okay, just for fun, let's do this one as well. Let's see what happens. Because, well, it never stops. It starts multiplying by negative numbers, so I guess that should be some stack overflow error. Oh. Yeah, because it's well, that's a classic mistake. I called fact and factorial was fine, so we were not really in factorial bad. Now, too much recursion. Yeah, it's like recursion is cool, but you don't want to have too much of it. Okay, so that's a good closing message.